Hello and welcome back to the devlogs for the game jam The Nightmare is Real. This is day 2 of progress, so let's get right into what I've done. If we switch over, we'll see that the first order of business, I made this like jagged line thing. Because today I was working on the spider and everything to do with the spider, and this was going to be used as a sort of range indicator or like area indicator for the line of sight of the spider. Um, I was planning to use a spotlight, um, but I knew that a spotlight wouldn't have clear defined lines, um, so it would be more of a visual like determinant of what the spider's state would be in, and not a way of effectively gauging the range of the spider. So I had to make a outline, a separate marker, and this is it. So now we get into scene, and we'll see, well, a lot of debugs and logging stuff, but the main stuff with the spider here is we have the light, which is, indicating like where cover is. Oh, not that one. Oops, that's the light. Oh no, I'm getting confused. Sorry. The light is this one. Just clicked on the wrong thing. That's what that does. It's a spotlight, and it's sort of a white color. The color changes depending on the state of the spider. It's a finite state machine, a pretty simple one, but it has 4 states. So searching, scanning, alert, and hostile. With the default being searching, and that's determined by the white color. I also did go ahead and change the platform to be flat, just to make things a bit easier. Here you see the decal, and all of this will rotate with the spider, so you can accurately see where everything is. We have this, which is a block, which I'm just turning off a render of using the collider for it. This is to determine if you are inside this area. There are 2 checks being done to determine if the player is detected, and it's if they are within this rectangle thing, within the trigger of this, it's set to trigger the mesh collider, and there is a raycast from this point, from the light, directly towards the player at all times. So if you're in the area and there is no line of sight blocker, then you'll be detected. We can go into the scripts and see what I've done. We'll start with a simple one, the area detection. What this is doing is basically when you enter the big trigger box, the Boolean in area, which is in the spider control script, is set to true. When you exit the trigger, it's set to false. Simple stuff. And we're just getting a reference for the parent in start. The complicated stuff is in here. We go to the top. This is effectively the entire control for the spider. We have some references to the objects that we'll need, some variables for speed of movement, and a cooldown timer. We'll come back to this. In area, what we just saw in the detection script. And this string is basically telling us which state the spider is. I know there's probably a more official way to use like enumerated values or something to get it to work more compact and succinctly, but I kept it simple just for the sake of being able to complete the project in time. And the light color, which I've been using to like determine what is currently the color of a spotlight and should it be changed at any point. So in update, we're every frame we're getting a log of what the state of a spider is in, and an if statement saying if it's in any of the states, then it should do the associated function, which spider scan, spider alert, spider searching. Yeah, and it will also say if the state is hostile and the color is not currently red, change the color to red, as an example. Same for scan, turns it to gold, alert also turns it to gold, and search to white. The scan state is for when the spider hears you step on an egg, and then it will snap to your position, and then it will, it will look there for a bit, and then it will go to alert. So I don't have the eggs programmed yet. So at the moment, it's just if I press G, it will scan. It will change to scan. We have the functions for each state. Spider or search is just rotating it at a slow speed. Alert is rotating it at a faster speed, and it will start a countdown for 7 seconds. It might be a bit longer. I think it should be 7 seconds. Hostile. If you're in the area, the hostile script is a bit all over the place. A lot of it is not in the hostile bit, which I would want to clean up given the option, but it works, and I don't wanna disturb it when it works. But I'll come back to this when we're doing the raycast script. And finally, the scan state, which when it starts, it rotates the camera to the player, and then it will start a cooldown. After the cooldown is done, it will change the state to alert. So when you're in hostile, it will change to scan. After scan, it will change to alert. After alert, it will change to search, and search is the safest. Okay, now we have the raycast function. I had a bit of trouble getting raycast to work, so I have a bit of commented out code. Basically, what this is doing is reading the collider of the first hit object of the raycast, and if that is equivalent to the player and the player is in the area, then it will change the state to hostile if it's not already in hostile. So if it's in any of the other states. I suppose an easier way to do this would be to say if state is not equal to hostile, then doing all of this. But yeah. There's a bit of maths going on with the raycast itself. So it's starting from the position of the light source. The location it's going to is the position minus the position of a player minus the position of the light source. The information of the raycast is going to hit, a variable called hit that we declare up here, and it will go on for infinity. It will also draw a debug ray so we can see what the line looks like in the inspector. And yeah. Here I'll talk about like the rest of the hostile stuff, because the information of the hit is stored mostly in this script. So if I want to access any information about the hit, then I do it here. The way to circumvent this is have some sort of Boolean variable that if the hit collider is equal to player, just switch a Boolean and then move all of this script to the hostile state. Anyway, as it stands now, this is how it goes. If the spider is hostile and the hit collider is not the player, then it will count down. It will count down from 7. It will change the state to scan and will set the cooldown to 3. And the cooldown is just how long it will take to transition to the next phase. So it will scan for 3 seconds, and then it will go to alert for so many seconds, and so on. Okay, so else, if the spider is hostile, and the tag is equal to the player, and they're in the area, the cooldown doesn't come down. This is like when the spider can currently see you. It will not... the timer to reset the state won't go down at all. It will just stay at 7. And finally, while the spider is hostile and the hit is like the raycast is looking at the player, the spider will always turn to face the player. That's what this is doing. Yeah. Go ahead and collapse that. Okay, so this is changing light color. We've got a reference to the component here. And the parameter, is it a parameter or an argument? This one's a parameter. The parameter is desired color. The arguments will send in, oh, I want white. So if a desired color is white, then we change it to white. One thing I learned when doing this is color.lerp. When you do new color, you don't use, instead the RGB plus albedo, they go up to 255 in the editor. These are not in code. They do not use values up to 255. They use values as up to 1. So when I did 250, 214, 255 values, those were like 250 out of 1. So it always put maximum values to everything, and it would make the light white, even when I put it for gold or even red, right? So to fix this, I divide all of these values by 255, so we get a percentage. So instead of 250 being our red value, it's 255, or 250 divided by 255, which is almost 1, basically. And we did that for gold, we did that for red. Same thing. Finally, we have a rotate to player script. I found this code online. If I'm honest, I'm not too fussed with how it works. Generally, it will take the player's transform, the transform of the object, and rotate between them at a certain speed, and that speed is variable depending on the variable that we set it to, and of course time.delta time, so we don't have any screwy frame rate issues. Okay, so that's that. Let's see how it functions in practice. So if we go back here to our game, let's start it up. This is the default searching state. You can see that there is in the scene view, we can see that there is the beam that will always go towards our character. Even if it sees us out of cover, as long as we're not in the area, it won't detect anything. If we press G, the spider snaps to our location, the color turns to gold, then it scans for a bit, and now it's in the alert state. And it will be like that for until the timer runs out. I'll demonstrate the timer once more, and it resets to 7 here. But the scan state only lasts for 4 seconds, so when we click G, which is our hotkey for scanning, it only will last 4 seconds, then 7 or 8 seconds for alert, and then it returns to searching. Now, if it sees us, it will start following us around, and the cooldown timer is 7 seconds. You can't quite escape it, but if you break line of sight, the timer will go down. But if you get seen again before the timer goes all the way down, then it will reset. But after the 7 seconds, it will rotate towards you one more time, and then it will start alerting and spinning at speed until the timer runs out, and it goes back to searching. So yeah, up next, I'd say that getting hazards working and what happens when you get detected. After that is figuring out how to drop a level and have everything transfer to the next level, and then it's just populating the scene. So that has been Day 2's progress. Thank you for watching. Goodbye.